Okay, YouTube, this is my next video on graphing logarithmic functions, in which we're going to quickly throw together this graph of y equals log base a half of x. And so, in terms of graphing logarithmic functions, one key task is really just to do this. Graph the exponential function that is the inverse of this first, and then what we'll do is we'll reflect it over the line y equals x. That is a line that starts at a y-intercept of 0 and has a slope of 1. We would say going through this line here, okay, are all the points y equals x. And so our inverse functions have to reflect over this line. Since we're really good at sketching exponential things anyways, we'll just go ahead and sketch that first and then reflect it over this line. So we would say that the inverse, okay, the inverse of the function that we have on the left here would be x equals log base 1/2 of y. So by switching our domain and range around, what we want to do now is isolate y. What we're going to do then is to rewrite this logarithmic thing exponentially. So to isolate y, we'll rewrite this exponentially. What we get is this. We would say, using our little circular remembering method here, we would say 1/2 is the base. We say 1/2 to the power of x is equal to y. And so I'm just going to clean this up a little bit here. We say this is the same thing as y equals 1/2 to the x. So in terms of what we see here, this exponential model, if we were to graph this, what we know about exponential growth or decay functions is that they have an asymptote, okay, on the x-axis. So I'm going to start by putting that in. We say y equals 0. And plugging in just some points here, let's go ahead and do this. Let's see what we end up with. We'd say, plugging in 0 first, we get 1/2 to the 0, which has got to give us 1. So 0, 1 is on our graph, as we should expect with all exponential functions of the form 1 times b to the x. But when we plug in 1, we say 1/2 to the 1 is 1/2. 1/2 to the 2 is 1/4. Going backwards, 1/2 to the negative 1 would be the same thing as 2 to the positive 1. And 1/2 to the negative 2 would be the same thing as 2 to the positive 2, which is 4. So graphing this, we could see that because our base is it's here, it's between 0 and 1, what we're going to get is a decay situation, at least with respect to our exponential function. So we would say that looking at this, we would say 1 comma 1/2, okay, 2 comma 1/4, negative 1 comma 2, and negative 2 comma 4. We would get this decay function right here, and I'm just not very good at drawing decay functions. Give me a second here, right there. So we're going to label this, and I'm going to label this is f inverse of x. This is actually our exponential thing. That's the inverse of the thing we're trying to graph. But because we're trying to graph this original thing here, what all we're going to do is this. We're going to switch the domain and range of these functions, meaning that we're going to start by flipping our asymptote to being on the y-axis here. So we would say that x equals 0 is our vertical asymptote. And then the next thing we're going to do is we're just going to take our table of values and we're going to switch them around. We say x f of x there. So we say x f of x, or we could say the same thing as y here. We'll take all these points here, which were on the right side, 4, 2, 1, 1/2, 1/4, okay? And we'll switch them with our x values, which were negative 2, negative 1, 0, 1, and 2. And so as we go graph these, we say 4, negative 2. Right 4 and down 2 would be here, okay? Right 2 and down 1 would be here. Right 1 and up and down none would be here. Right 1/2 up 1 would be here. And then right 1/4 and up 2 would be really close to the y-axis. What we get is a logarithmic function that looks like this. Now, remember I said that logarithmic functions grow more and more slowly. We look at something that's decreasing extremely rapidly, but as it comes down here, it just levels off. It really, really levels off, just like this here. And so this would be our logarithmic function right here, f of x, or log base 1/2 of x. So to describe domain and range here, we could see that at least with our graph, all x values that are positive work with our logarithmic function, or that is, our logarithmic function crosses all x values greater than 0. But with respect to range, we see that it starts way up here at positive infinity, and because it's always going to be decreasing from left to right, it's never going to stop going downward. It means that we're going to hit all real y values on our y-axis here as our range here. So all real y values is our range. Cheers.